Let's look at the rules for solving absolute value equations. If we want to solve absolute value equations, the first thing we need to do is get the absolute value by itself. So if you think about how you solve linear equations, get rid of add or subtract, then get rid of multiply or divide, works the same way. Notice that I have put this in capital letters. The reason I did is because students forget it all the time. You cannot distribute into absolute value bars. The distributive property is for parentheses only. Once you get the absolute value bar by itself, then you will take whatever is inside of the absolute value bar and set it to both plus or minus, because remember, we're talking about the distance from zero. That makes the absolute value bars go away. They're no longer needed. Then we can solve for x. We always have to then go back and make sure that our solution really does work, because sometimes we get what we call extraneous solutions. That is when you get an answer mathematically, but then when you go to check it, it doesn't really work. So let's look at, I think I have 3 or 4 examples here, so let's look at some examples of what this is going to look like. So in example 1, the first thing I'm going to do is get the absolute value bar by itself. So I'll subtract 5. So then I will divide by 2, because again I'm not going to distribute. So then I get the absolute value of 3x minus 1 equals 14. So I'm going to ask myself, if 3x minus 14 is a distance of 14 from 0, that would mean, I'm going to kind of show you graphically first here. So here would be 0, here would be 14, here would be negative 14. That means this expression, that 3x minus 1, can either be right here or it can be right here. So 3x minus 1 can either be negative 14 or 3x minus 1 can be positive 14. Either way, I'm a distance of 14 from 0. That is what step 2 is telling you to do. So now from here, I'm going to solve each of these equations for x. So I add 1 to both sides and divide both sides by 3. I get x equals negative 13 over 3 for one of my solutions. Doing the same over here, I get 3x equals 15. Again, dividing by 3. I get x equals 5. I do have to check both of my solutions. I'm hoping I have enough room here to actually check these. I'm not sure if I gave myself enough room or not. So first thing I'm going to do is plug negative 13 over 3 back into my original equation. I'm going to have 2 times the absolute value of negative 13 over 3. 3 times the absolute value of negative 13 over 3. Forgot the 3. Minus 1 plus 5. I want to know, does that actually equal 33? So first thing I'm going to do, order of operations tells me to start with a parenthesis or any kind of other grouping symbol. So in this case, the grouping symbols are the absolute value bars. So starting in there, I get 2 times. Nice thing here, when I multiply 3 times negative 13 over 3, 3's cancel. Negative 13 minus 1 plus 5. That gives me 2 times negative 14, absolute value plus 5. So that's 2 times 14 plus 5, which does equal 33, so it does check. If I do the same thing with x equals 5, let's see, I'll do that in green. Then I'm going to have 2 times the absolute value of 3 times 5. I'm going to go ahead and take that in one step. So I'm going to do this 3 times x right here just because I didn't leave myself very much room. Minus 1 plus 5. I want to know, does that equal 33? Well, I know 15 minus 1 is 14, so I have 2 times the absolute value of 14 plus 5. Well, that's then going to be 2 times 14 plus 5, which again I've already seen does check out. So that does work. Both of these solutions work. So there's my first solution. Here's my second solution. Okay, I'm going to go ahead and I'm going to solve example 2. So, whoops. Let's see if I can erase that. Maybe not. Okay, so I'm going to go ahead and do example 2. Yeah, well, let me erase that. First thing I'm going to do is get that absolute value bar by itself. So I'm going to add 2 to each side. Sorry about that line. And I get absolute value of 2x plus 5 equals 3x plus 6. Again, what is this telling me? That this is telling me that 2x plus 5 has to be a distance from 0 of 3x plus 6. So just like when 3x minus 1 was a distance of 14 from 0, I could say that it was up here at positive 14 or back here at negative 14 because both are the same distance, because we do not talk about distance in negative numbers. I'm going to do the same thing here. I'm going to say that if I looked at 0, 2x plus 5 could go in the positive direction to 3x plus 6 or in the negative direction. So I'm going to go ahead and set that to be 2x plus 5 can be the negative of the whole expression. So I show the whole expression by using parentheses. Or 2x plus 5 could be equal to just 3x plus 6. So then I'm going to solve each of those. So if I solve the first one, I get 2x plus 5. I start by distributing negative 3x minus 6. Then I can either subtract 2x from both sides or add 3x. I'm going to go ahead and add 3x, giving me 5x plus 5 equals negative 6. Subtracting 5 from each side, I get 5x equals negative 11, and x equals negative 11 fifths. So there's my first possible solution I got. Doing the same thing, solving the second equation here. Again, I'm going to subtract 2x. I can start there. There's nothing to distribute on this one. And I get 5 equals x plus 6. Subtract 6. I get negative 1 equals x. So I have to check both of those. So I'm going to kind of go in the space of example 3 here to check these. So checking the first answer of negative 11 fifths, I get absolute value of 2 times negative 11 fifths plus 5, absolute value, minus 2 equals 3 times negative 11 fifths. Those are just parentheses that I'm plugging in with, plus 4. That gives me absolute value of negative 22 over 5. Plus, I know that in order to add those, I'm going to have to go have a common denominator. So I'm going to do that in this step and go ahead and say 5 is the same thing as 25 over 5. Minus 2 equals negative 33 over 5. Same thing, I'm going to say that that's going to be, I'm going to get a common denominator and say minus 20 over 5 instead of saying minus 4. Which then gives me absolute value, negative 22 plus 5 is absolute value of 3 fifths minus 2. Is that equal to negative 53 fifths? So absolute value of 3 fifths is 3 fifths. This is 2 over 1, so 3 over 5 minus 10 over 5. Does that equal negative 53 over 5? Well, I know that 3 minus 10 does not equal negative 53, so even though I got negative 11 fifths as an answer, it does not work. Okay, that's my extraneous solution. I also need to check negative 1. So I'm going to go ahead and slide this over to check negative 1. And I get absolute value of 2 times negative 1 plus, I'm not going to have room there. Let's see if I can move this over anymore. Let's see, I'll try to write smaller. Absolute value of 2 times negative 1. And maybe I'll just do that 2 times negative 1 right away. So absolute value of negative 2 plus 5 plus, minus 2. Does that equal 3 times negative 1, so negative 3 plus 4. Sorry, just don't have quite enough room on this little screen I use. Negative 2 plus 5 gives me absolute value of 3 minus 2. Remember, this is negative 3 plus 4, which is 1. So 3 minus 2 equal 1. You bet it does. So here is my only solution for this one. Okay, so again, the other solution was extraneous. So let's look at example 3 here. So I would divide both sides by negative 3, and I get the absolute value. So sorry, I'm kind of all over the place on this video. So if I divide here by negative 3 and divide here by negative 3, I get absolute value of x plus 4 equals negative 3. Okay. So we have these steps that I gave you, but sometimes you have to be able to think logically through a problem. So if absolute value means distance, and for that reason we make absolute value in the end should always be positive, is the distance from 0 going to ever be negative 3? It doesn't matter what's in here. I'm never going to have a distance that's negative. Once the absolute value bars are all by themselves, if it is equal to a negative, I know that will never happen, so I'm going to go ahead on this one and say no solution. I do not even have to really do any math with it, other than that first step of dividing by -3. But if I draw your attention over here to this side note, notice here maybe your initial reaction is, oh, it's negative, there's no solution. But my absolute value bar is not by itself yet. Notice if I divided both sides by -3, I would get x plus 4 absolute value equals +3. So notice I could solve this by setting x plus 4 equal to 3 and x plus 4 equal to -3. So giving me x equals -1, x equals -7. And again, then I would go back and check those. So checking those solutions, I get -3 times -1 plus 4 would be absolute value of 3. Does that equal -9? I can see that, yes, that will equal -9. If I plug -7 in, I would get -3 times -7 plus 4, so -3. Does that equal -9? Again, I can see that because this will become positive, that will also work, so I do end up with both of those solutions working. So big thing with absolute value bars, when you're solving them, always remember to first get the absolute value bar by itself. Then think about that in terms of distance, which is going to allow you to set the expression without bars equal to both the positive and negative of the other side. And then once you solve, make sure you check for extraneous solutions. But be aware that once you get the absolute value bars by itself, if it's equal to a negative, there will not be any solutions.